2023 second term Wezary questions. Question number 1. How many radians are equal 128 degrees? To convert degree to radian, we can have multiple ways, and for this question, simplest way is dividing 128 degrees by definition, measure of 1 radian. 1 radian is 57.3 degrees. So when we divide them, we will get the correct answer. 128 divided by 57.3. Answer is 2.23. 2.23 radian. So B is the correct choice. Question number 2. The wheel on an upside down bicycle moves to 11 radian in 2 seconds. So this is angular displacement delta theta. This angular displacement happens in 2 seconds. What is the wheel's angular acceleration? Yani alpha, if initial angular speed is omega initial is 2 radian per second. This is 4 times ask minister question. So we are going to use the third kinematic equation. Delta theta is equal to omega initial delta t plus 1 over 2 alpha delta t squared. This is the one of the question in the book. 11 radian, omega initial is 2, delta t is 2 plus 1 over 2 alpha 2 squared. 11 is equal to 4 plus, this is going to be 4 over 2 alpha. So 3 is equal to 2 alpha. Alpha is equal to, 7 is equal to 2 alpha. Alpha is equal to 3.5 radian per second squared. So B is the correct choice. Question number 3. Which equation is correct to calculate centripetal acceleration? The question for centripetal acceleration is R omega squared correct. R omega is VT. R squared omega squared, no. V squared omega squared over R, no. This is V squared over R. So this is also incorrect. So is the correct answer. Question number 4. An object moves in a circle at constant tangentials. Which of the following is not true for this object? So first, if it is moving in a circular path, C is not 0. But constant speed means tangential speed 0, and also alpha angular, tangential acceleration is 0, angular acceleration is 0. So centripetal acceleration is directed towards the center of the circle. Yes, centripetal acceleration is always directed to the center of the circle. Tangential acceleration is 0. This is correct. This is also correct. Centripetal force acts on it. If there's a centripetal acceleration, there must be a centripetal force, correct. Object is in equilibrium. No, it's not in equilibrium. And because if an object is accelerated, AC is linear acceleration, so there is no equilibrium. So this is the correct choice. A car of mass 1,000 kilogram moves in a circular track at the constant speed Vt. If the circumference of the track is given to you, so calculate the force that maintains circular motion of the car. Calculate this Fc, we need to use mv squared over r equation. So r must be calculated from the circumference. Circumference is 2 pi r. So r is going to be circumference divided by 2 pi. Circumference 6280 divided by 6.28. This is going to be 100. 1,000, not 100. 1,000 meter. 6,280 divided by 6.28 is 1,000. This is radius. Well, that's right. In this equation, Fc is 1,000. Vt is 25 squared. Radius is 1,000. This thousands will simplify. Square of the 25 is 625. Newton is the correct choice. Is B. Question number 6. A girl at a state where slings a ball in a vertical circle at the end of a string. What is the tension force applied by the string at the bottom of the ball's path? So this is vertical circle, and in this vertical circle, the ball is at the bottom in here. So there are two forces acting on the ball. One of them is gravitational force, downward to the ground, to the center. The other one is tension force acting along the string. And if we write a centripetal force equation in here, which is Ft is pointing the center, so positive. Ft is away from the center, so negative. Then write Ft equation, because Ft equation is the question. Ft is Fc plus Fg. Then we are going to add gravitational force and centripetal force. So it is equal to weight of the ball plus centripetal force. So B is the correct choice. Question number 7, two uniform solid cylinders of equal radii roll down an inclined plane without slipping. The first cylinder has 3 times the mass of the second cylinder. Torque exerted on the first cylinder is how many times second cylinder? So if an object is rolling on an inclined plane, and the force which causes the object to roll is the gravitational force, yani Fg. Fg causes torque. And this torque questions about the, what torque. Yeah, it's about the torque. So mass proportional Fg proportional to torque. And if the first cylinder is 3 times of the mass of the second one, and gravitational force 3 times, and the torque is going to be also 3 times. So it's going to be 3 times. Question number 8, identify which conditions of equilibrium hold for a bicycle park. If it is parked, so linear speed is 0, angular speed is 0, linear acceleration is 0, angular acceleration is 0. So both conditions hold, both rotation and translation equilibrium holds for this bicycle parked. Question number 9, at which of the 7 positions indicated in the figure should the supporting pivot be located to produce a net negative torque? So we know that X rotation is going to be between these two forces, somewhere between them. And according to this X rotation, Ft 25 Newton produces a negative torque, and 75 produces a positive torque, counterclockwise rotation. So if we want negative net torque to be greater, there is a net negative torque. Negative torque produced by 25 Newton must be greater than positive torque produced by 75 Newton. For that reason, the X rotation must be on the closer to 75, because if it is closer to 75, linear arm of the 75 decreases and linear arm of the 25 increases. So then torque of 25, which is negative, increases. Torque of 75, which is positive, decreases. So your point is going to be C, B, or A. One of these points, or more than one, we will check one by one, will produce a negative net torque. For that, as an A, B, F is impossible. C and F is impossible. So A or B is going to be one of the choices. So let's choose point A. Let's check the point A first, if A is correct or not. I'm going to say if this is the point which produces negative net torque, I'm going to choose here as rotation. So this is 1 unit. Distance is 1, or Librand 1 unit for 75 Newton. So it produces a positive 75 Newton meter torque. But other side is going to be 1, 2, 3, 4, 5, 6, 7 units. 7 times 25. 7 times 25 will produce 25, 2 times 7, 175 Newton meter. So 175 Newton meter is produced by the negative torque is produced, 75 is positive is produced. So when we add them, 175 negative plus 75, so it's going to be negative 100. So it's a negative net torque, which means A is the correct, D is the correct choice. What about B? Why not B? Let's check B by again writing the givens. So if the exaltation would be B, So in this case, distance and lever arm for 75 is going to be 2. Lever arm for 25 is going to be 6. 2 times 75, it's going to be negative 150 Newton meter. 6 times 25 is going to be, let me calculate it, 6 times 25 is going to be also 150, but this is going to be positive 150, this is going to be negative 150. When we add them, result is going to be 0. So then B is no rotation point. So correct answer is going to be in this case D. And this question is the question which is in the book, one of the chapter question. It says that a mass is attached to cord that is wrapped around the wheel with a radius of 10 centimeters as shown in the figure. The acceleration of the mass down the friction's incline is measured to be 2 meters per second square. Assuming the axle and wheel are to be frictionless, determine the moment inertia of the wheel. So now, first we should calculate what is the tension in the string, because this tension in the string produces the torque. So to calculate moment inertia, there are two ways. We have to know mass of this disc or pulley. It's not given. That's why we cannot use it. Another way is I am going to torque is equal to I times alpha. Maybe by this way we can find this moment inertia. But to find this, I have to know what is alpha, and I have to know what is torque. To calculate torque, tension force must be first calculated, because tension force produces the torque. To calculate the tension force, we are going to use 11th grade dynamic problem solution way. So the forces acting on this mass is, one of them is the gravitational force. So Fg, let me draw it a little green with red one. Okay. So this is going to be Fg is acting down to the H, which is downward to the ground. And Ft is acting along the rope, and Fn is acting perpendicular to the surface, because normal force is perpendicular. And as you see, Fg has two components. One component will be acting parallel to inclined plane. Other one is going to be acting perpendicular to inclined plane. The perpendicular component, I will say Fgy. Parallel I will say Fgx. So then I see that acceleration is acting along the incline. So then the force, which is, I have to write the Newton's second law in here, net force along the acceleration direction, which is, if I say this is x, this is x, if I say this is x component, x-axis, this is y-axis. Always draw the x-axis along the acceleration. So is going to be m times a, and the force is acting along in the same direction of the acceleration. I will write as positive, and Fgx is going to be positive. Ft is going to be negative, because in the opposite direction of acceleration, is equal to m times a. Fg calculated by Fg times sine of inclination angle. Inclination angle is given as 37 degrees. This is studied in the 11th grade, so I'm not going to prove it again. Always the horizontal component, the component parallel to inclined plane, is calculated by Fg times sine 37. M is going to be m times a. Let's write everything in here. M is given as for the mass 12 gram. G is 9.81 times sine of 37 is minus Ft is equal to m. M is given 12, and acceleration is given as 2. So now let's use the calculator. 12 times 9.81 times sine of 37 is going to be 70.45. minus Ft is equal to 2 times 12, which is 24. So transfer Ft right side, positive 24 to left side as negative. So it's going to be 70.85 minus 24 is Ft. So minus 24 is 46. Ft is 46.8 Newton. So after calculating Ft, now I can calculate torque produced by Ft on this pulley. This is the center of the pulley, is the axis of rotation. So tension force is acting tangent to the disk. So that's why angle is 90 degrees. So torque is going to be Ft times distance from where the force acts until axis of rotation, which is the radius of the disk. And after that, I'm going to write this Ft in place. Or you can write this Ft times R directly in here. So they will simplify. Ft times R is going to be moment of inertia equation for disk 1 over 2 R squared. Pardon, we are going to calculate moment of inertia, sorry. I use the question. Alpha can be calculated because this disk surface is direct connected to the rope. So the rope's acceleration is going to be tangential acceleration of the rim of the disk, 2 meters per second squared. From this, we can calculate alpha because we need alpha, as you see. Alpha is equal to tangential acceleration of the rim divided by radius. So I can write in here tangential acceleration divided by radius. And transfer this 8 over our other side. So then I is going to be the tension force times R becomes R squared divided by AT. So now let's put everything. Ft is given as, we have calculated as 46.8 times R is 0.10 centimeter, 0.1 meter. AT we calculated, pardon, AT is given as 2, which is the acceleration of the object, which is 2. So multiply by 0.1 squared divided by 2, which is 0.24. 0.24 kilogram times meter square. So B is the correct answer. And yes, it is B the correct answer. My choice is given A. Let me check it later. And question number 11, one of the following is a SI unit of angular momentum. SI unit of angular momentum, kilogram times meter divided by second. So we know angular momentum I times omega. I is kilogram times meter square. Omega is radian per second, but radian has no dimension. We don't write radian in combination of the other units. Just we write 1 over second, so it's kilogram meter square per second. A disc rolls along a horizontal surface at a constant linear speed without slipping. What is the ratio of its translational kinetic energy to total kinetic energy? It's a disk. C is equal to 1 over 2. So kinetic energy translational over total. Translational over kinetic energy total is the question. Translation kinetic energy, we know 1 over 2 mv squared. And for a rolling object, total kinetic energy is 1 over 2 mv squared plus multiplied by c plus 1. So this 1 over 2 mv squared will simplify. So then translational kinetic energy over total kinetic energy is going to be 1 divided by c plus 1. So let's write it. 1. C is 1 over 2, which is the disk, plus 1. The rest of them is gone with calculation 1. It's going to be 3 over 2. So when we flip it upside down, it's going to be 2 over 3, which is C. Is the correct answer. How does the restoring force acting on a pendulum bob changes as bob swings towards equilibrium position? So restoring force is 0 at equilibrium position and maximum at maximum displacement. So from maximum displacement to equilibrium position, of course, restoring force must be decreasing. Restoring force decreases, so B cannot be answered. Acceleration and restoring force directly proportional, so decreases and decreases, so C cannot be answered. What about velocity? Maximum at equilibrium position, it increases, so A is the correct choice. Question number 14, a simple pendulum's length is given as 0.25 meter, period is 1 second. What will be the period of the pendulum if its length becomes 1 meter at the same place? So it is initial length, this is final length. So as you see, length increased by 4. So final over initial is going to give us the change factor. So 1 over 0.25 is going to be 4. So change factor of L is 4. And we know that period is proportional to root of length. So initial period is 1. I know 1 is equal to root of L, but if length increases by 4, then root of 4L. So because it's a root, take the root of 4, it's going to be 2 times root of L. Root of L, we said it's 1. So 2 times 1, it's going to be 2 seconds. Okay, if length increases by 4 because there's a square root, so period increases not by root 4, it's root of 4 and 2. So D is going to be the answer. A simple pendulum can be used as an altimeter on a plane. What will happen as the plane rises from the ground? So period will increase. Why? Because L over G as this airplane rises, so G decreases. If G decreases, because chapter 1, section 2, we know G is capital G, mass of Earth divided by square of the distance from the center of the Earth as the airplane rises. Of course, R increases, G decreases. If G decreases, period should increase. Period will increase. If period increases, frequency should decrease because they are inversely proportional. Both A and C are correct. A wave whose particle vibrate perpendicular to the direction of the wave motion is called transverse wave. Sound wave is longitudinal wave, so A is the correct choice. What is the wavelength of the sound wave shown in the figure? So crest to crest to crest. Crest to crest, we know it is 1 lambda. From one crest to next crest, it is 1 lambda. So 2 lambdas, total length is 1. Lambda is going to be 1 over 2, yani 0.5 meter for this question. Two successive crests defines wavelength from crest to crest, or two successive travel. Each crest passes a given point every 12 seconds. So from this, we can calculate the frequency. So how many crests passes? 8. In how many seconds? 12 seconds. So 8 over 12, 8 divided by 12, which is 0.67. 0.67 hertz is the frequency. What is the speed of the wave? We know the speed of the wave is lambda times f. Lambda is 1.2 multiplied by 0.67. So multiplied by 1.2, result is 0.8. So 0.8 meter per second is the speed of the wave. Should the following wavelength will not produce a standing wave on a string that is 30 meter, 5 meter long, this is the length. Remember, lambda is equal to 2L over N is the equation for calculating the wavelengths which produce standing wave. But this time, wavelengths are given. So if this wavelength gives us integer for N, so which means it's a standing wave. If it's not integer, it's not going to be a standing wave. So let's do it 1 by 1 for 1.75. 2L, L is 3.5 divided by 1.75. If it is integer, it's a standing wave. Not integer, it's not a standing wave. 2 times 3.5 divided by 1.75. The result is 4. Yeah, it's integer, so it's a standing wave. So we are looking for not. This is not the answer. The other one is 2 times 3.5 divided by 3.5. So just second order. It's also a standing wave. It's not the answer. The other one is 2 times 3.5 divided by 5. Yeah, this is integer, not integer, sorry. If it is not integer, it's not a standing wave. 2 times 3.5 divided by 5 is 1.4. This is a traveling wave, not a standing wave. So C is the correct answer. A bat flies towards a fixed wall. Fixed wall, so sends an ultrasound wave of frequency at which of the following equation is correct to calculate the apparent frequency and pitch frequency of this wave when it strikes the wall. So we're going to consider the wall as an observer, so it's a fixed, so observer's speed is 0. And wave, a bat flies towards, so bat is here source. It's approaching towards means f prime must be greater than f. So I'm going to write f prime equation, vf times v plus minus vo divided by v plus minus vs. So observer is 0. So because f prime should be greater than f, so then the denominator also should be big now, a small number, sorry. To make it small number, of course, you should put here negative. So that's why equation is going to be f prime is the f times v divided by v minus the source. The source is in here is the bat. So it's going to be A. Correct choice is A. The intensity of the sound is 1 watt per meter square. What is relative intensity? This is threshold of pain. Threshold of pain. Its relative intensity is 120 decibel. If the amplitude number 2 is set in motion, this one, which pendulum will also give larger amplitude? Yani which two pendulums are in resonance? Okay, larger amplitude of oscillation with larger amplitude happens if there is a resonance. So then they should have the same initial frequency. So this why the length must be the same, of course, or is the one which is at the same length with second pendulum. Which of the following represents first 3 harmonics for pipe closed at one end? We know in closed at one end, F1, F3, F5, yani fundamental frequency F1, next one is 3 times F1, next one is going to be 5 times F1. Which one is so? Let's check it. If this is fundamental frequency F1, next one must be 3 times F1, yani 150. So this is not correct. It is 150, and third one must be 3 times of 50, 3 times of 150, pardon, 5 times of 50, it's 250, so B is going to be the correct answer. So if F1 is 50, 3F1 is the next one, 3 times 50, 150, next one is 5F1, 5 times 50 is 150, so C is going to be B. Two currents run in opposite direction, two parallel wires A and B at a distance of 1 meter apart. If the current of A is 1/3 of B, determine the position of the point along the line normal to the wires where the total magnetic field is 0. This is the chapter question. Two wires carry current in opposite directions. One of them shaded up to the page, the other one shaded down to the page. Wire A, wire B. Wire A has a current of B over 3. This is the B. And separation between them is 1 meter. So if two currents carry opposite directed currents, magnetic fields are not going to be 0 between them. So it's going to be a point beyond and closer to smaller currents. Which one is smaller current? So is smaller current. So somewhere in here, say that separate distance from the small current to the point where the magnetic field is 0 is X. In this case, two things must be provided. One of them is at this point, whatever this point is, the magnetic fields must be opposite in direction. So if you check by right angle, we are going to see A has a magnetic field out of the page, B has a magnetic field into the page. So one of the rules is the second one is their magnitudes must be equal. Yani magnitude of the magnetic field because of the current A, and magnetic field because of the current B must be equal to each other. Equation for calculating the magnetic field of the straight wire is mu I over 2 pi d. So for both of them, mu and 2 pi is same. That's why I'm not going to write them. So because they will simplify when I make them equal. Electric current of the wire A divided by distance of wire A is going to be electric current of wire B and distance from wire B to the point. So electric current of the A is B over 3. It's given the question. Distance from A to the point is X. And electric current of the B is IB. And distance from B to the point is 1 plus X. These IBs will simplify. So here is going to 1 over 3X is equal to 1 over 1 plus X. After cross product, it's going to be 1 plus X is equal to 3X. So 2X is going to be 1, X is going to be 0.5 meter. So 0.5 meter from wire A is the correct choice, or 1.5 meter from wire B, also correct choice. A solenoid of length is 50 centimeter has a 2000 turns. Length of solenoid is 0.5. Number of turns is 2000. Calculate magnetic field in the middle of solenoid when the current is 10 ampere. It's very easy. Mu I n over L. Mu is 4 pi times 10 to the power negative 7. I is 10. N is 2000 divided by L is 0.5. Use your calculator. 4 times 3.14. 4 times 3.14 times 10 to the power of negative 7 times 10 times 2000 divided by 0.5. Answer is 0.05 Tesla, or 5 times 10 to the power negative 2 Tesla. So this is the correct answer. In which situation the direction of the magnetic force on a proton moves in a magnetic field is out of the page? So out of the page. Magnetic force should be out of the page. We know that magnetic force and magnetic field can never be in the same plane. So that's why if magnetic field is out of the page or into the page, you cannot say that magnetic force can be out of the page. So that's why A out of the page, B is into the page. So then cancel them. Then answer is going to be B or D, one of them. Apply right-hand rule for proton, palm, magnetic field down to the page. Make your forefinger down to the page. Thumb must show to the left. Lie your hands on your page. Thumb left, forefinger down to the page. Palm is going to be out of the page. Yes, B is the correct choice. What is the magnitude of the magnetic force on an electron when moving perpendicular to the magnetic field? So QVB. QVB is the question. In figure 2, parallel wires each carrying direct current determine the direction of the movement of the electrons in wire 2. They repel each other. Look at them. The forces are away from each other, which means they repel each other. If the electric currents are opposite in direction, they will repel. So the electric current of the second wire will be down to the page. But electron motion and electric current are opposite. So electron motion of the second wire is going to be up to the page. So this is the correct choice. So electric current is down to the page, but electron motion must be up to the page. Okay, question number 29. I think that's okay, must be corrected for this one. According to right-hand rule, which of the following figure correctly describes the direction of the current for the magnetic field? Okay, you are going to check them one by one. So let's do A. Electric current goes from back up and front down. From back up front, down, back up, front, down. So I see that. So on the loops of the coil, electric current is at the back up, in front, down. Then put your pen on your palm so that your forefinger at the back of your pen, it must be up, curl it towards the front. In the front, it must be down. When I do like this, I see my thumb points to right side. Right side is going to be N. So this is not correct. For B, electric current goes as it's from positive at the back up, front, down. And back up, front, down, back up, front, down. So again, your forefinger must go from back up and curl your forefinger front down. Thumb is going to be again right side is going to be, and this is also not correct. In C, this time electric current again from back up, front down, back up, front down, front down, front down, back up, front down. So again, put your pen on your palm. So electric current is back up, front down. So right side is N. Again, this is correct. This is correct. But in B, it is complete opposite. This time front up, back down, David. Front up, back down. So this time your forefinger must go from front up at the back down. So this time thumb will show left side. This is N pole. So C is the correct answer in this question. Eddy currents are used in, for instance, carbon. This is several times asked question. Everybody knows answer. And a generator's coil has 25 turns and cross-section area 36 centimeters square, 36 times 10 to the power negative 4 meters square. Be careful. Centimeter and centimeter squares are different. The maximum EMF developed and the generator is 2.8 volt, which is E max. At a frequency of 60 Hz was the strength of the magnetic field. I will use the E max equation, which is BA and omega. BA and omega. Then B is going to be E max divided by A and omega. E max is 2.8. Area is 36 times 10 to the power negative 4. N is 25. Omega is 2 pi f, 2 pi 6.28. F is given as 60. Close the bracket. So then use your calculator. 2.8 divided by bracket 36 times 10 to the power of negative 4 times 25 times 6.28 times 60, close the bracket. Answer is 0.083 Tesla. 0.083 Tesla is the correct answer. Commutator is not used. Commutator is used in DC. DC motor or DC generator. Used, not used is AC. A toaster is plugged into a source of alternating EMF with an RMS value, so V effective, and heating element designed from the current, the maximum value. This is IM. Resistance of the heating element, R. We are going to use the Ohm's law. R is equal to VE over IE, but IE must be calculated first. IE is IM over root 2. So 110.5 divided by root of 2. So 10.5 divided by root of 2. This for 7.42 ampere. Then use Ohm's law. V effective is 110 divided by I effective 7.42. 10 divided by answer, it's going to be 1. I think I did incorrect. 110 divided by 7.42. Answer is 14.8 ohm. So this is the answer. If the expression of the instantaneous current and the instantaneous potential difference across the pure self-inductance is given, this is Im value, this is omega, this is Vm value, this is omega. We know in coil, potential difference is leading, that's why pi over 2. Calculate the coefficient of self-induction of the coil. So L is question. First, we should calculate XL. XL, you know, is equal to Vm over Im, E over IE, because maximum values are given. I will use your maximum values. 125.6 root 2 divided by 2 root 2. Root 2 will simplify. 125.6 divided by 2, 62.8 ohm. Then use Excel equation. X is equal to 2 pi, not 2 pi, because omega is given, just write omega. Omega L, so L is going to be XL over omega. XL is 62.8. Omega is 100 pi and 314 divided by 314. Answer is 0.2. 0.2 Henry is the answer. A source of frequency F, if its potential difference 100 volts, effective potential difference is connected across a capacitor. If the effective current of the circuit, which is IE, is this, calculate maximum charge Q maximum C times V maximum. C times V maximum. We should first calculate C. In here in the question, there is no C given. We check it. No. So then first we should calculate C. After that, we can do that. To calculate C first, XC must be calculated, which is V effective over I effective. So V effective is 200, I effective is 10, which is going to be 20 ohm. Now use the XC equation and calculate C 1 over 2, 2 pi FC, then XC and C, place them. C is going to be 1 over 2 pi F X. Okay, 1 over 2 pi F is 100 over pi times XC is 20. So these pi's will simplify. Let's get C. 1 divided by bracket 2 times 100 times 20, close the bracket. It's going to be 2.5 times 10 to the power of negative 4 farad. So then apply in here, because maximum potential difference must be calculated. First, it is 200 to 2. Effective is given. So it's then maximum charge is going to be 2.5 times 10 to the power of negative 4 times 200 root 2. Let's do it all times 200 times root of 2. Answer is 0.071. So, or 707 times 10 to the power negative 2. So this is the correct answer. Question number 36. In electric circuit in this adjacent figure, calculate the phase angle difference between total current and potential difference of parallel connected circuits. Theta tangent inverse IC minus IL over IR. In parallel connected circuit, we calculate theta like this. Tangent inverse IC is 0.25, IL is 0.084 divided by IR 0.16. So 0.25 minus 0.085 divided by 0.16, then shift tangent, pardon, Here, tangent. So 0.25 minus 0.085 equals divided by 0.16, 1.031, shift tangent answer. That's 46. 46. Please. This is the correct answer. Potential difference of 0.75 volt is needed to provide a large current for arch welding. So this is small potential difference. If the potential difference across the primary of a step-down transformer is 170 primary V1, so this is V2 then, what is the ratio of number of turns of the wire on the primary to secondary? Yani primary and 1 over N2 is question. And then 1 over N2 and V1 over V2 are directly proportional, and 117 over V2 is 0.75. So 117 divided by 4.75, it's going to be 156 over 1. So B is the correct answer. AC power is transferred for far distance by high potential difference and low current is the correct answer. You step up transformers. So the following must be true for two waves with identical amplitudes and wavelengths to undergo complex destructive interference. The waves must be 180 degrees out of phase all the times. A double slit interference experiment is performed using the blue light of hydrogen discharge tube. So it's given the fifth order bright fringe M is equal to 5 is seen at angle theta. How far apart two slits separated? T is the question. So d sine theta is equal to m lambda is the equation. D is equal to m lambda over sine theta. M is 5, lambda is 486 times 10 to the power of -9. You should convert nanometer to meter, divided by sine of 0.578. So now let's use it. Calculators. 486 times 10 to the power of -9 divided by sine of 0.576. Result is 2.42 times 10 to the power of -4 meters. So B is the correct answer. According to blah blah principle, any points on a light wave front can be treated as a point source of wave. It's the Huygens principle. So in which region of the following waves does the maser microwave laser? Microwave. So what is another word of quantum of light? Photon. Quantum of light. In the photoelectric effect, if the frequency of the incident light is increased with the same intensity, which are the following is true. Frequency increases, photons energy increases. So speed of the emitted electrons increases according to kinetic energy maximum equation. Energy of the photon minus work function. So if frequency of the incident light increases, of course, kinetic energy, so speed of the emitted photon increases, correct. Kinetic energy of the rejected electron increases, correct. Number of emitted electrons does not change, also correct, because it depends on intensity. But the question says same intensity, so all answers are correct. Which of the following frequencies the emission of electrons from a metal surface of work function 3.3 occurs when light shines on the surface of the metal? So the following frequencies, the emission of electrons from the metal of the surface of work function 3.3 occurs when the light shines on the surface of the metal. So let's calculate the minimum frequency of the photon by using H times F is equal to work function HF. Also, at that frequency, it is the minimum frequency of the photons that must be, that causes the electron ejection. Work function is given 2.3 electron volts times, of course, we should convert the joule by multiplying 1.6 times 10 to the power equal to 19, 10 to the power negative 19 joule. And ages, we know 6.63 times 10 to the power of negative 34. So calculate the minimum frequency. So F is going to be 2.3 times 1.6 times 10 to the power negative 19 divided by 6.63 times 10 to the power of negative 34. Close the bracket. I'll use the calculator. 2.3 times 1.6 times 10 to the power of negative 19 divided by bracket 6.63 times 10 to the power of negative 34. Close the bracket. Answer is frequency is given 555 times 10 to the power of 14 hertz. So any frequency greater than this number is going to be 5.455, sorry, will cause electron ejection. So greater, it will cause. Less, it will not cause. Less, it will not cause. Less, it will not. Pardon, 5.1014. So it is greater, it will cause 3.4 10 to the power negative less 1.2 times 10 to the power of 15. So if it's 14, it's 5.8. So there are two answers. One of them mustn't be the answer. 5 point. So the both A and D seems to be the answer. I am going to check this question again. Okay. Which was maybe there's this type of mistake. Question number 46. To measure the Compton shift, which of the following waves are simply used? For Compton shift, X-rays photons are used. Which of the following summarize the Thomson's model of the atom? Thomson's model, according to this model, electrons are like embedded in a sphere. So electrons are embedded in a sphere of the positive charge. B is the correct answer. Which solid has a valence band that overlaps conduction band? Valence band and conduction band overlaps in conductors. And in transistors, outer region called emitter and collector. The narrow region is called base, which are the following mystery. Emitter is more heavily doped than the base. This is correct. Emitter base junctions forward bias are correct. Base collector is reverse bias correct. So all answers are correct. In which of the following a superconductor could not be used? Heating element. You cannot use the heating element because these superconductors resistances are 0. If no resistance, no heat is emitted. So this is all about 2023 second term Wezary exam.